So let's go through a few examples of using these properties of logarithms to help us rewrite. And one of the objectives was to be able to expand a given logarithm into a sum or difference of logarithms. So what does that mean? Well, let's take a look at an expression like this one. I've got the logarithm of 10 to the times z squared. That base, remember, if you don't see the base written there, we consider that to be a common logarithm. And the base of a common logarithm is, everybody? That's right, it's 10. So when I rewrite this expression, let's think about what rules we're going to be using right here. For one thing, I know that I've got a product of two quantities, 10 and z squared. So I'm going to split it apart using my product rule. So that means let's take the logarithm of 10, the common logarithm of 10, and add that to the common logarithm of z squared. If you are unfamiliar with these rules, it is my considered advice to make sure that you use only one rule at a time. Don't try to do it all in one fell swoop. It doesn't mean you're smarter. It just means that you memorize some of those rules, but we need to be able to make sure that you have a complete understanding of this. So let's rewrite it once again. There is another rule that can be used right here if you recognize that we also have an exponent going on over here in this expression. So what we really have right here is the expression the logarithm of 10 added to 2 times the logarithm of z. So now is there anything else that can be done? Well, yes. We actually know what the logarithm of 10 is, and if we have a part of an expression that we can rewrite, we should certainly do that. So we're going to take the logarithm of 10 and we're going to rewrite that. That logarithm of 10 is equal to 1 because it is a logarithm base 10 of 10. So we're going to be adding 1 plus 2 times the logarithm of z, and this is now a completely rewritten expression. Well, how about this animal down here? What do I do with all of this? I've got the logarithm base 2 of 32xy squared over 4x cubed y. And what I should really do, as in most expressions in algebra, I should work from the inside out. So before I even start doing anything, we should really try to simplify this expression inside of parentheses. So what have we got? Well, we know that with 32 divided by 4, that's 8. So we can actually reduce that. We'd be taking the logarithm with a base 2 of 8 in my numerator. The x and the x cubed in the denominator actually cancel out, and it gives me x squared in the denominator. And of course, y squared and y, that reduces, and it gives me just plain old y. So what can I do here? Well, I now know that I've got a quotient, and so I'm going to use that quotient rule, and it says let's take the logarithm base 2 of the quantity 8y and subtract from it the logarithm base 2 of x squared. Well, there is certainly more that we can do right here because we still have a product. When we write 8y, it does mean 8 times y. So let's split it apart again. We've actually got now the logarithm base 2 of 8 added to the logarithm base 2 of y. And of course, my last term right here, I've got that exponent. And just like I used my exponent rule above, I can put my exponent in front and treat it as 2 times the logarithm base 2 of x. Does that mean we're done? Well, in fact, there is one more we can do, right? And that is this logarithm base 2 of 8. And that's going to become 3. So we're going to have 3 plus the logarithm base 2 of y minus 2 times the logarithm base 2 of x. And that would be our completely simplified or expanded expression. Okay, one more along these lines right here. Let's talk about this one. This one looks a little bit kooky. What could I do with this? Well, I've got the natural logarithm of the cube root of xy divided by e. What do I do with all of that? Well, recognizing first and foremost, that I have a difference or quotient right here, I can actually divide. So I can treat this as the natural log of the cube root of x times y, and subtract from that the natural log of e. So what do I do with this cube root? Is that it? Is I'm stuck? Well, no. Remember that we had a rule right here. Our rule stated that if we have a root, the nth root of some value a is the same thing as that value a raised to the power 1 over n. So we can actually rewrite this in a way that's a little bit more useful to us, rewriting it as the natural logarithm of x times y raised to the 1/3 power. Right? And of course, don't forget, what is the base of the natural log? Well, it's e. So this guy over here thinks he's the logarithm base e of e, and we know that that would equal 1 because as long as the base is equal to the argument, the result is equal to 1. So we're minus 1 right here. All right, what do I do now but take that power down in front again? So I'm going to have 1/3 multiplied by my natural logarithm of the product x times y, all minus 1. And I see once again I've got a product right here, so there's actually one more step, and it goes like this. We're going to have 1/3 times the natural logarithm of x added to, don't forget that 1/3 would distribute, to the second term is 1/3 times the natural logarithm of y, all of that minus 1. And this would be our completely expanded expression. Okay, so that's our set of rules. We'll come back with a few more examples in the next video.